we'll be going over how to run a regression and a regression with multiple variables in R. And we're going to do this in R for this reason. You all see what is on the screen right now, and this is how to run a regression in Excel. While it is possible, it takes a lot of time and a lot of effort and can be extremely difficult, time-consuming, and confusing, especially when you're trying to learn this and understand how this all works at the same time. So when we move over to R, our screen looks a lot better already. We've imported our data, and in our data frame here we have the number of books that a student has read and their grade on a recent English exam. And we're going to see if the number of books affects their grade on the exam significantly. We're just going to run a regular OLS, ordinary least squares, regression in R, and the command for that is just LM, or linear model. We're going to store this model in an object called model1. And as usual, we have our y variable first, so our dependent variable, grade, being regressed on our independent variable, books, or number of books that a student has read. When we run this line, we'll get an object called model1. And when we run summary model1, we get this beautiful little summary here that summarizes the whole regression that we just ran. And we can see from our p-value here in the books row that this model is statistically significant, or the number of books a student has read does have some meaningful impact on their most recent English exam grade. Down here, we can see our R squared value, which is how much variance in our independent variable or our dependent variable that our model explains. So if we calculate this as a percent, it would be 24.2% of variance in exam grade is explained by number of books that the student has read. In terms of multiple regression, R tends to keep that pretty simple. Let's clear our workspace. And let's load up our multiple regression data. In this data, we have some wages. This is hourly wage rates, so $11.73 an hour, $6.40 an hour, so on and so forth. And we have two dummy variables indicating whether a person is black and whether or not they are from the South. What we're going to do is we're going to run a linear regression of wage on being black and being from the South to see if those two variables affect your hourly wage in any kind of significant way. We're going to call this model 2, and we're going to run the same kind of model, an ordinary least squares regression, with the LM command. So we have LM, we have our y, our dependent variable wage, and we are regressing that on our two dummy variables, being black and being from the South. If we run that, it stores our model in an object called model2. And if we run the summary command on model2, it will bring up our whole summary of the data, our regression and our multiple variables, and we can see that being black and being from the South both impact hourly wage rate in a significant way. And we can see from the estimates that they are negative. And so we can determine that the relationship between being black and hourly wage is a negative relationship, meaning the way that we interpret this is kind of funky because being black is a dummy variable. So you either are or you are not. Now, being black doesn't really go up or down, but because this is stored as a numeric variable, the way that we might interpret this is because when you're not black, you have a 0 in this data set. But as being black increases, or as one goes from not being black to being black, the wage would decrease. This illustrates a negative or inverse relationship. As one variable increases, the other decreases. Or, in a much more simple way to interpret, being black has a negative effect on hourly wage rates. Being from the South also has a negative effect on hourly wage. And being black and being from the South has a negative effect on hourly wages. So people who are black and who are from the South will make less on average per hour than those who are not either of those things. And we can see that this difference is statistically significant dependent upon being black and from being from the South. And that is how to do a regression and a multiple regression in R. And it makes it a whole lot more simple than all the work that we'd have to put in Excel.